Hello, fourth graders. This is Mr. A. I hope you're having a wonderful day. And we are looking at the first page of our homework, which is about comparing fractions. And there are three types of problems they're going to ask you, okay? They're going to ask you fractions that have, they're going to ask you, or you're going to have problems where you're going to have the same numerator numerator and different denominator, or you're gonna have same denominator, or you're gonna have different numerator rated and denominator. Okay, so we're gonna try to do all these different situations. Okay, so you're gonna have a situation where the numerator is the same. So let's say we have 2/3 and 2/4. Okay, so here the numerator is the same. Both fractions have two pieces, but the size is different. Okay, so two pieces of different sizes. And then here we have um, same size, let's say, same size, but different quantity, different number of pieces. And maybe we'll have something like this. We have 3/8 and 4/3, let's say. Okay? So when you have any fractions, you have to remember what fractions are. And fractions are parts of a whole. Okay, fractions, they all belong to a whole. They are part of something. Okay, so when we have two fractions, we have to draw two rectangles, one for each fraction. And it's very important too that we keep the whole or keep those two rectangles the same because we are referring to the same whole, the same quantity. However, they are partitioned differently. So if we look at the first one, 2/3, our denominator is 2. So we have to always start with the denominator. Okay, 3 is an odd number. So I'm gonna draw my thirds, okay? 4 is an even number, so half of 4 is 2, okay? And half of 2 is 1. So I broke my whole into fourths, okay? And now this is in thirds and this is in fourths, okay? Now let's put the pieces. Let's put how many are available. So the fraction tells us that the numerator tells us that there are two pieces of thirds, and the second fraction tells us that there's two pieces of fourths. Okay, so it's not surprising to us that 2/3 is the bigger number than 2/4 because thirds are thicker than fourths. Fourths are skinnier than thirds. So if we have two pieces of thirds, that's going to be bigger. That's one thing. The other thing is 2/4 is half, right? Because 2 is half of 4. But half of 3, half of 3 is 1, 2. So we have 1.5, right? So half of 3 is 1.5, and we have 2. So this is more than a half. The 2/3 is more than a half. So we used a model to compare our fractions. I used here benchmarks. I used the half benchmark to prove that 2/3 is bigger. I mean, you could have proven it differently. Like you could say like, okay, 2/3 and 2/4. Let's create a common denominator between the thirds and the fourths. So I'm gonna use the multiple of thirds and see when does 3 and 4 be the same. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Okay, those are the multiples of 3. Let's use the multiples of 4. 4, 8, 12. And I can stop at 12 because I see already that 3 and 12 and 4 can be the same at 12. So 3 would need 1, 2, 3, 4 to become a 12, and 4 would need 1, 2, 3 to become 12. Now I'm trying to rewrite 2/3 and 2/4 as equivalent fraction, just changing the partitioning but not changing the amount. So this 2/4 becomes 2 times 3 is 6 pieces of 12s, and this 2/3, when I multiply it by 4 over 4, that's 8 pieces of 12. 8 pieces is more than 6 pieces, so that also is another way to prove that 2/3 is bigger than 2/4. Okay? So one scenario is that you have the same numerator but different denominator. Same number of pieces available but different sizes. The second situation is you have the same size but different number of pieces available. So we have 1/3 and 2/3. This means we have 2 pieces of thirds, so this one is the bigger fraction. It has more amount than this one, 1/3. The last situation that you would have with fractions is when you have different numerator, different denominator. So the sizes are different and the number of pieces available is different. So what do we do here? Well, you can use your benchmark. Okay, so 3/8. If we look at 3/8 using bench mark, if we use the whole benchmark, 3/8 is less than a whole, because if we have a whole, that would be 8/8, right? That means we have all the pieces, but we don't. We have only 3, so this is less than a whole. If we use the half, okay, half of 8 is 4/8, because 4 makes half of 8. If we have 3/8, that is 3 is less than 4, so 3/8 is less than 1/2, right, fourth graders? Same thing if we do with 4/3. If we use the benchmark, if we want to get a whole, we would need, and we have 3 parts. That means we would have all the pieces available, so that would be 3/3. If we have 4/3, that means 4/3 is more than a whole, because you need 3 pieces of 3 parts to get a whole complete set. So if you have 4/3, that means 4/3 is bigger. And the answer is already clear. You have one fraction is less than a whole, and the other fraction is greater than a whole, so 4/3 is bigger. Okay? So remember to use those strategies that we are practicing in class, and you can check with any of them, with a model. You can check with a model, you can check with the benchmark, you can rewrite one of the fractions as an equivalent fraction, or create a common denominator. Okay, so I look forward to seeing your work. Make sure it is Make sure that you do the job right so it counts, and do it well so I remember. So I want to see diagrams, I want to see your work, I want to see your thinking, and see evidence that you are growing. Thank you, and I'll see you next time.